Green methanol promises to be an interesting alternative fuel, particularly for shipping applications or for aviation fuels. Laboratory space is often an issue. Today I'm going to introduce you to our container-based green methanol synthesis unit. We'll start here in the first module where we have our automation system. This unit is based around PCS7, which is a Siemens system. We have the control cabinets here, which are in a non-X environment. The operator system is located in this first module together with the Riddle control cabinets. The second module that we have here contains all of the thermostats, air compressors, etc. that we need for the operating infrastructure of the unit. So here we have the air compressor, provides a 6-bar air for actuating valves, etc. Here we have the thermostats, which give us the necessary cooling capacity to ensure that we can remove the heat of reaction during reaction, as methanol synthesis is quite an exothermic reaction. Last but not least, one of the more exciting parts of the unit is the actual plant itself. As you see here with this container-based system, you have really easy access from both sides. There's also a number of manholes in the top so that the user can access parts with the crane from the top. Some of them are fairly heavy to remove. As you see, for example, here, we have the Sarah compressors. This is a dual compressor system at the front end for compressing the synthesis gas coming from the client side up to the required reaction pressures. We also have a second compressor here, which is for gas recycle. We're operating 2 water-boiled fixed-bed reactors, which can be operated in series in this case, and we're recycling intermediate gas. I'll take you on the inside and show you what the rest looks like here. This is a completely explosion-proof space here, so all of the components that are in here have been chosen to be ATEX compliant. Here is one of the fixed bed reactors, and as I said, this is a water-boiled reactor system. One of the first units we ever did this way, and the client specifically wanted this type of heating cooling system because it represents the type of reactor heating and cooling that you use at an industrial scale. So the hope is that they'll have better scalability here. Again, 2 reactors in series, and we have the complete online analytics is here as well. So we have a variety of time-resolved ABB gas analytics here, based mostly around infrared, which give us continuous time-resolved online gas analysis. And if the client wants to look at more in depth at the various byproducts formed during reaction, we have a Siemens Process GC, which allows the client to be able to look at many more components in a very quantitative fashion, but with less time resolution than the online analytics from ABB can do. Again, you've got the slop container here, which collects the methanol in the end. You get an idea here of how much is formed. And the entire unit will be delivered in this module to the client in the near future. We're just finishing the FAT right now on this unit in our workshop. If you'd like to learn more about how ILS can help you with container-based solutions or with green methanol R&D, feel free to contact us. And thanks for listening.